In just a few moments, we'll be entering a world of very small things. Our activities will have to be very precise ones. So before we get involved with all the details, let's pull back a bit. Let's take a much broader view of this repair world of ours. See what it is we're going to accomplish and just how we're going to go about it. The assemblies that we'll be working on have changed dramatically in the past few years, both in their appearance and their operation. A great variety of them may come into us for repair, each one made somewhat differently than the others, and performing very specific functions. In fact, any one board may be just an isolated part of a much larger system, yet have single modules on it that perform 100 functions of their own. So there's simply no way we can know in detail how all these circuits operate. And yet, we're about to learn exactly how to repair them. How is that possible? Let's look for the answer first in what we mean by repair. When things were simpler, repair usually meant two combined tasks. The first was to find the fault, and this could usually be done with some relatively simple diagnostic test. The second task was to correct it. Most cases involved not much more than clipping out a bad part and soldering in a new one. One person could do it all. With many boards today, this is no longer possible. Diagnosis alone may be extremely complex. You often need very sophisticated test procedures, and you have to have a detailed understanding of entire systems. Just finding the fault has become a specialty all by itself. What we mean by repair in this course is what happens next. After the failed component or damaged circuitry has been identified, and we need to take some physical action on the board to restore it to its original condition. It's possible to do this on almost any board without knowing exactly how the circuit works. The key to it lies in understanding the basic elements of construction that are common to all boards, and the procedures needed to first take them apart to some extent, correct the problem, and then put them back together again. In a sense, we become our own process engineers, because this kind of repair can involve a number of processes, and they have to be done in a particular sequence. Let's compare what we need to do for a moment with the manufacturing process. In general, a typical board will go through a number of steps. First, the base material is cut to the correct size. Then all the holes are drilled with automated machinery that's precisely controlled. The circuitry comes next. It's masked, developed, and etched, and then it's plated. Then the components go on, and the joints are wave soldered. The completed board may have been through 10 or more individual steps, each precisely controlled and standardized. The whole process, though, goes only in one direction. It's highly automated, and the people involved need to be highly skilled in only single tasks that they do over and over. Compare that to what's required in the repair situation. It's a bidirectional process. You have to demanufacture the board to some extent and then remanufacture it to its original quality. There is only one person involved who has to have a broad range of knowledge, as well as the skill to duplicate the results of automatic processing equipment. It's a tall order, and one that has put competent repair people in great demand. Performing repair today requires a work system, one that brings together a number of elements, since no one of them alone is enough. 5 elements make up our system. So take a guess at what the first one is. Most people will look at a repair setup and say, tools. All the tools come first. You know why they're wrong? Because the tools themselves have no brain. If I had one of these in my pocket, and I put it around my neck, it wouldn't make me a doctor. No, it's not the equipment. It's the person behind it. It's you, your knowledge, your skill, and your ability to apply it to the problem. You're the first and most important part of the system. Let's see what comes next. A defined range for the problem. In other words, what's the scope of each repair job? What exactly needs to be done? And what are the physical characteristics of the board? We need to know them in detail, because in large part, they'll dictate the repair procedures we'll need to use. Then comes the third element in our system, the specific procedures. There are a number of them to choose from, so our first job is to select the appropriate ones for each problem, and then establish the sequence in which we perform them. What do we do first, and why? And what do we do second, and why? And what comes after that? Only after we've done this are we concerned with the fourth element in the system, the tools. Some you're already familiar with. Others are specialty systems for desoldering, machining, and circuit rebuilding. The final element in our system is quality assurance. These are the standards that define the acceptability of the end result. Not only what it looks like when you finish, but exactly how it was done. Many times, only you will know that. Each of these 5 elements, then, make up the repair system, and we'll be considering them in detail throughout the course. So, we begin to see that repair is a much more sophisticated function than most people realize, and we'll go one step further in defining it. By repair, we mean non-destructive repair, work that leaves the board as reliable when we're finished as it was when it was originally manufactured. Don't forget, when you pick up a board to work on it, you could be playing in a very high-stakes game. Just a few seconds of excess heat could damage a board in a way that you couldn't see. And it might still work at first, but in use, a day later, or a week, or a month, it fails. Then who knows what might happen? Let's consider that for a moment. Let's start with consumer electronics and what happens when this fails. Sure, it's not life and death, but it's very frustrating, and it can be costly, and it may take a long time to get fixed. Failure here, though, can exact a much higher price. When circuits and medical equipment stop working correctly, human injury is likely to follow. Electronically controlled systems surround all of us every day. They handle our communications and direct our industrial processes. And in some situations, time itself becomes the critical factor. Life or death is literally hanging in the balance here. Imagine a breakdown right now with navigation and guidance equipment going out. Maybe they get back all right, but maybe they'd be just a little too late. And how about something like this? Imagine the human and economic costs of failure here. The circuit boards behind a layout like this one aren't something you'd want to put in the hands of an amateur. Not if you had to bring it home. There's no way to predict the cost of failure exactly. But what we can know, and have to know, is that our work was not the cause of it. Quality assurance is not something we can leave up to someone else, because the appearance of a repair job is no guarantee that the board's reliability has not been lowered. That depends on exactly how the work was done, and only you will really know that. And remember, the more reliable a board is to begin with, the further it will be degraded by poor repair. This course will give you the basic knowledge and skills you'll need to work on almost any board. Let's take a look now at what we're going to cover. First, we'll uncover the basic elements of construction common to all boards. We'll learn the various types of materials used as the base and study the nature of the circuitry with its pads and runs and voltage planes. We'll see how components are mounted and the types of solder joints involved. Overall, we'll learn how to read a board, analyze its construction in detail, because that's the first step in any repair. Next, we'll look at all the common methods for joint removal. We'll weigh the advantages and limitations of various desoldering methods and see how to select the most appropriate ones. Our choices will be based on the physical characteristics of particular joints and the forces that interact during the desoldering process. Then we'll cover coating removal. This is often the first task you'll be confronted with in the repair process, and we'll see how to safely remove each of the different types. Since the board may have to be recoated, we'll learn the various techniques for doing that as well. Then we move into damage repair and cover all the problems you're likely to encounter. You'll see how to replace damaged conductors and missing pads, what to do when faced with a burned out section of circuit board and you have to remanufacture the whole area. And then we'll get to edge connectors, how to repair lifted ones or completely replace them. The last step in repair is often a replating job on the connectors, so we'll cover that too, and see how to do electroplating using a portable swab plating system. The problem of electrical damage to sensitive components comes next. We'll look at each of the possible sources of overloads and see how to either eliminate them or protect the work against them. It's a full course in repair, and from it you'll learn what to do in each case, how to do it, and exactly why it's done that way. And then with practice, you'll be well on the way to becoming a master craftsman. They're badly needed in this field, and needed now. So let's get started. The training room is across the hall.